Hey, welcome back to another math lesson today. Welcome to the magical world of algebra. We're going to kind of dive into some basic facts, basic concepts in algebra. These are things you need to know to really, proceed forward, to move forward in algebraic learning, thinking. So we're going to be doing adding algebraic terms is going to be our goal for today. Before we even begin that, I think it's important that we get some terminology down. If I have an expression, this is a an expression would be like 5x plus 3. We're going to add, subtract, multiply some terms together. If I have this expression, 5x plus 3, let's kind of break it down to what everything in this expression is called in the world of algebra. Now, these are both called terms. A term is basically a number, a variable, or a number being multiplied by a variable. So we have two different types. We have what's considered a numeric term. This is basically a term that is just a number. Just a number. It's our numeric term. Or you can have what's considered an algebraic term. Now, an algebraic term, this is a term that has a variable in it. So we're going to go ahead and, that's the first part we're going to look at here. Now, with that exact same thing we're just looking at, let's look at this 5x plus 3. Here, we're going to break this down even further. We're going to say that when you have an algebraic term, you always have two parts to it, no matter what. If it's an algebraic term, you always have two parts. You first have your variable. Now, my definition of a variable is basically, now I guess it would be considered a letter or a symbol that's used to represent an unknown quantity. That's how I define what a variable is. And so in this case, we're going to use x to define a variable. And go figure, you've actually been dealing with variables probably since you were little kids, like in the first grade, when you had like a square plus 3 equals 5. What does a square equal? You were dealing with variables. It was just not a letter. It was a box or an apple or whatever they used to use that unknown amount. But you've been doing this for a lot longer than you probably thought. Now, this number part, it has a special name. It is called a coefficient. And so when you have an algebraic term, the numerical part, the number part of this is called the coefficient. Now, what about if we just have a number with no variable? This is our numerical term. We call this a constant. And again, a way to think of this is kind of like with credit cards. We have fixed rate, we have variable rate. Fixed rate is what we are all striving to get when it comes to our loans, our credit cards, whatnot, because a fixed rate, as what you would think in the name, it does not change. It is fixed. It's almost like set in stone. A constant, it is set in stone. A 3 is a 3. It's just a 3. However, a variable, 5x, it could be anything. It depends on what x's value is, so it can change. Just like a variable rate on a loan, it can change. They can say, well, right now it's 2%. Oh, sorry, it's 5% now. Sorry, it's variable. It changes all the time. So that is the difference between like a variable and a constant. Constant is always the same. Variable, or in our algebraic term, it can constantly change. It really just depends on what the value of the variable is. What we're going to do today is we're going to focus on simplifying expressions. Some with decimals, some with fractions, and some with fractions that have uncommon denominators. Unlike denominators, we're going to have to change. So our instructions here would be simplify each expression. And hopefully you'll find this to be fairly easy. Now, let's start off by saying this. What if I had, I'm going to do fractions to begin with because I think it's actually easy to explain this. What if I had, for number 1, I had 1/4 x plus 2/4 x. And one way of looking at this is using a style of learning that Singapore math uses called bar modeling. So I have a bar here. We're going to say this bar is split up into 4 equal parts, and this bar represents x. So I'm going to first just go ahead and have my bar here, and I'm going to make a couple, I'm going to make an extra bar over here. I may need that later. We're going to say this bar right here is x. Okay, this whole bar right here is the value of x. Now, if I take these two bars, right here and right here, and I'm going to go ahead and say that, I don't know why it's doing that. All right, if I take my two bars here, and I will say that the first bar is worth 1/4. So what part of x is this? Well, it's 1/4 x. So I'm going to go ahead and say this is 1/4 of the x being filled in. Now, the bar on the right-hand side, it's 2/4 x. Now, I'm going to just move it over a little bit. You could fill it in wherever you like. I'm going to fill mine up in the middle for a reason. So as you can see here, I have 2/4 of it is filled together, right? Now, what happens when I watch it when I slide over? If I add the 1/4 to the 2/4 x, watch what happens. It's like magic. Boom. We now have 3/4. So as you can see right here, 1/4 x plus 2/4 x equals 3/4 x. And so we don't need to have the bar. I mean, you can use it if that helps you when adding this, but what you can do is you can just say basically 1/4 plus 2/4 equals 3/4, and it's 1/4 of an x plus 2/4 of an x, therefore it's 3/4 x. Hopefully that makes some sense. If you get that main idea that we're talking about here, you're going to find this to be very, very easy. I really like these if you understand what we're doing here. I'm not quite sure what this 1 is over here for. We'll just go ahead and erase it. All right, so let's go ahead and try a problem, another problem with fractions. We'll say, I'm going to go ahead and start this over. We'll say that we have 1/5 x. I will make it y. Why not? 1/5 y plus 3/5 y. Now again, if I do 1/5 plus 3/5, I get 4/5. That means that 1/5 y plus 3/5 y is going to equal 4/5 y. That is all there is to it, just like that. It is as easy as it looks. It's nothing tricky about it. Pretty straightforward. Hopefully that makes some sense. We'll do one more with the fractions just to make sure you're getting this. What if I have 5/9 w? Now you'll notice that the terms, I'm changing the variables to different letters. They can be any letter you like. It really doesn't make a difference. So we're going to do 5/9 w plus 7/9 w. Now, in this case, we're going to have 5/9 plus 7/9 equals 12/9. Now, I know that before we had talked about writing 12/9 as a mixed number. In the case when we're dealing, now we're in algebra, I kind of alluded to this before on the last lesson on multiplying, dividing fractions. You're going to want to go ahead and keep this as an improper fraction when dealing with algebraic terms. And so what we're going to do here is we're just going to simplify it. So 12/9 is the same thing as we can divide them both by 3. It's 4/3, right? So this equals 4/3 w. Now, at some point, you may begin to wonder, do I have to show my work underneath the problem like I've done in both of these? You can, but you don't have to. It's completely up to you. Okay? So let's go ahead and say we're going to move on to decimals at this point. You know what? We'll continue with fractions. Why not? We're going to do more complex fractions. Let's say that we have 2/3 x plus 1/4 x. All right, now this one's a little bit more complicated because we have thirds and fourths we're dealing with. So if I had 2/3 plus 1/4, I would want to rewrite this with a common denominator. So I'm going to go ahead and make them into twelfths. So 2/3, 3 times 4 is 12, so 2 times 4 is 8. And 4 times 3 is 12, so 1 times 3 is 3. And this will get me 11/12, right? So my answer to this problem is going to be 11/12 x. Again, all we're doing here is we're adding the fractions, and we're going to tag along the variable. It's just saying, it's kind of like saying we have 2/3 of a pizza plus 1/4 of a pizza equals 11/12 of the pizza. I don't know how big the pizza is, but I know I have 11/12 of it. Let's try another one. One more of these fraction ones. Let's say that I have 5/6 n plus 1/2 n. Now, if you're getting pretty smart at this stuff, you may be able to convert it ahead of time. You may want to say, all right, this equals 5/6 plus, well, 1/2. I can multiply both of these by 3 and make this 3/6. I add them together, I get 8/6. I need to go ahead and simplify this so I can divide them both by 2. And I'm going to get 4/3. So this will equal 4/3 n. Hopefully that made some sense for you. Our last type of problem we're going to look at is, well, if you like decimals, it's going to be the easier of the ones. If you like fractions, well, it's not that much more difficult than fractions. We're going to be doing it with decimals. So let's go ahead and have our number 5 here. And we'll do 0.7 plus 0.7y, excuse me, plus 0.6y. It is the exact same idea. We're going to add the decimals together and then tag along that y. So again, if you want to show your work, you can. If you can do this in your head, that's great. Maybe you can try it in your head right now as I work. I'm going to drop this decimal down. 7 plus 6 is 13. Carry the 1. 6 times 0, I'm sorry, 1 plus 0 is 1. So I get 1.3. So my answer for this one equals 1.3 y. And that is my answer. Not too bad. Not too bad at all. You're doing a great job. Okay, it's time for our final question of the evening. Hopefully we can get through this and have no problem with it. Number 6. Let's say that we have 3.6 m plus 1.3 m. Again, maybe you want to do it on the side, maybe you can do it in your head. Maybe you say, well, I know 6 plus 3 is 9. 3 plus 1 is 4, so this is 49. 36 plus 13 is 49. 3.6 plus 1.3 is 4.9, and it's just going to be m. That's your answer, 4.9 m. Okay, that is your lesson on adding algebraic terms. I hope this made perfect sense to you. Have a wonderful evening, and we'll talk to you later. Bye.